we're going to play a little game. 2 truths and a lie. My kids love to play this game. First one, generative AI systems, specifically transformer models, have been shown to scale indefinitely, meaning the bigger they get, the more powerful they become. Second one, the latest transformer models like GPT-4 are now leveraging quantum co-processing units. These units enable the model to tap into the superposition principle, allowing it to process all possible answers to questions at once, collapse the wave function into the most probable answer, and give you a very accurate response. And then the final one, with the ability to generalize from minimal examples, sometimes as few as 1 or even none, generative systems can execute tasks without explicit prior training. Who thinks that's the lie? Okay, got some more hands. More hands. Okay. Number 2 is the lie. We haven't tied anything into a quantum co-processing unit yet, but it might happen in the future. Actually, the third one, that's kind of fun. That's called zero-shot learning. So you can actually just say, this is the task I want you to do, please do it. You give it an example, and then it can do it. And the largest models can actually flex and do that a little bit, right? So incidentally, this was really fun. I used GPT-4 to tell me lies about itself. It was like, okay, I want you to tell me some potential lies that I'm going to play this truth and a lie game. And it was very upset about it at first. It's like, well, no, I don't like to lie. It refused to give me a lie. But I said, but I understand in the spirit of what you want to generate, this is all in fun. So here's some lies. And it gave me some interesting lies. But then 2 of them were no longer lies. And this was back before the latest refresh of GPT-4. One of them was a telepathic interface. So, having an implant that could then translate information into the large language model, which would allow it to generate the outcomes of what it's reading in your mind. And I actually saw a really fascinating article in the Wall Street Journal that was tied to, I think it was at MIT. This is a person who had locked-in syndrome. They couldn't speak. They couldn't do anything. The only thing they could really do was move a dot on their glasses to point at a screen, and that camera would pick up where the dot was located and then be able to slowly assemble a phrase or a word or a sentence, right? So they then trained a large language model on this person's mind, and the outcomes from that allow that person now to communicate. And the system actually works quite well. The other one was dream rendering. So with dream rendering, what they were doing is they were taking a person, putting them in an fMRI, and they show them a whole bunch of images. And then they record what the fMRI outputs look like and train the system on that output for that person. They fine-tune it. Then they put the person back in the fMRI and tell them to go to sleep. I don't know who can sleep in an fMRI. I probably couldn't, but some people can. They slept. When they got into REM, we could actually effectively visualize the dreams. They were blurry, but we could tell what that person was dreaming about. And after they were able to kind of remember it and say, yeah, and validate it. So GPT-4 thought that was a lie too. It wasn't a lie. I read the paper on it. It was very interesting. So what does this all mean? Okay. It tells you that everything is changing really, really fast. Okay. So Gartner's study, talking to their customers, identified that half of them had already increased AI investment from the potential of ChatGPT. And that makes sense, right? That system went from effectively 0 users to 1 million users in 5 days. That's the fastest growth of any technology we've had. And that sent a kind of sonic boom through technology. Everyone was like, wow, I gotta get on this. So all the leaders everywhere are on top of it. But what's the most important here is seeing this quote at the bottom from Kathy Wood of ARK Invest. And the quote is essentially saying productivity gains are the big outcome of this. Now, how is it productivity gains? Well, if you have been using it, you probably already know. It lets you do a lot of stuff really fast and really easily, right? Some of the most low-hanging fruit we're already aware of is using Copilot when you're writing code, right? That is a great way to speed up your productivity. It writes your test cases, it writes some basic in functions, does a pretty good job of kind of eerily predicting what you want to do in your function if you did a good job of naming it. So that's a really fast and interesting way of seeing this kind of productivity gains. But there's more interesting things that are coming from that. What we're starting to see now, and I'm going to talk about this tomorrow, is the digital human economy. But what that is large language models being deployed to help people in roles that are largely boring. So let's say you're a first line customer service agent, and really your job is to just kind of take some heat or, answer some rudimentary questions. It will probably be nicer to have an AI, which probably won't get mad or burnt out, handle the first level conversations, and you can redeploy your people to handle higher value conversations after that. So think about it from an IT perspective, which is another possible use case. You could have it being your first line technical support. Hey, we got chatbots that kind of answer questions today, but nobody likes them and nobody wants to use them, and everybody says agent as fast as possible to get through to a human. These systems are at least a bit better. They are at least, they feign interest in what you're saying, right? They'll be like, oh, I'm sorry to hear that. That actually really sucks. Let me try and help you with this problem, right? That's what makes them better for those simple upfront tasks. And then as soon as you get past a level where that system can't help, you can hand over that work to the human who can do the higher value work and have a better support experience for your customer. So there's lots of possibilities. You can also have legal assistance, right? These systems are able to index vast amounts of data. We used to call text data unstructured. It's not really unstructured for a large language model. It can read it all, it can understand it, it can put it into a vector database, shuffle text like cards, right? Or you can fine tune a system based on it so it even knows how to speak the language, essentially, of the output that an expert would expect. So there's a lot of possibility here, and a lot of industries are looking at it. And if your industry isn't looking at it, or you're wondering where to start, I challenge you to kind of change your mind and think anywhere I could add productivity to my business might be the place where I want to consider adding this in to add productivity. So one thing to keep in mind, though, is it's incredibly complex. This is an eye chart at best. You can't really see this, but there's all kinds of things to think about. There's, cleaning up your data so that it's useful, having data pipelines, understanding the best prompt engineering that works for you, having an ML ops deployment scenario, having the underlying infrastructure designed to handle all of this, and then putting that all together in an operational pattern, tying it into third-party systems so that you can actually get additional value out of it. Right? There's a ton of work that needs to be done. It's incredibly complex, and your time to value can be really long. So what we've gone ahead and done is create a validated design for generative AI. So like I started this out with, there's a lot of industry that's looking at building large language model systems for their business, okay? If your business is creating large language models to support other businesses, creating those large base pre-trained models like Llama 2 or GPT-4 or Falcon 40 or whatever, then you're customer type 1 is what I would say. You're the one who's building an enormous infrastructure to train these systems on. Then there's customer type 2 that we're seeing today, which is a SaaS user. And these are the first customers that are jumping at this. They've probably signed up to GPT-4 and are using the product. They might be using the playground in the background or the API to do additional work. Or they may be using Copilot, not the coding one, but the Microsoft version, right? They might be trialing that right now. A lot of businesses are looking at moving into those, and I completely agree with this path. That is one of the more productive, forward-thinking things to jump into, get your feet wet, start to see what it can do for your business to increase your productivity, and then you're probably going to start getting into a situation where you might want to fine-tune a model for your business. So in order to do that, you need something that's based on a best-in-class infrastructure that Dell can provide, right? It's going to be a high-performance platform. It's going to be the kind of thing that's paired with NVIDIA GPUs or potentially AMD GPUs. You're going to need some expert support. And what it does is it allows you to create that cycle of use that's required with your own fine-tuned model. You need to be able to identify the use case, identify the data that's required, fine-tune and train that system, deploy it for inference so it can actually do something, figure out where you went wrong and it didn't work, refine the model, refine the data, and continuously improve that system over and over. And we have already built out a validated design to support this, which includes your ML ops layer. It's partnered closely with NVIDIA, so we're using their models on top of their frameworks. We have a Rails system to support protecting your data and making sure that your large language model isn't being rude to your grandma, right? And ultimately, that's going to let you build an enterprise-wide solution that will support whatever you need. And fundamentally, this is all built on top of our offerings. So we have GPU-ready designs that can be liquid-cooled or air-cooled. They have multiple GPUs built in. Typically, you're pairing all of these systems across multiple hundreds of systems. If you're doing inference, you might only need one or two. Depends on your model, right? Tie that with best-in-class networking, storage offerings, the NVIDIA AI for Enterprise software that I already talked about, ML ops platforms that we've already validated and architected for the system, and then run that all through our services and support organization. And we can help enable you to get to an AI-proven outcome. So on top of that, we can help you. We understand it's hard. That's why we built this. So on top of that, we can help you. We can get you involved with our consulting services, which will help you identify low-hanging fruit that will let you start with your AI journey in your business. We have customer solution centers distributed globally that can actually help prototype your AI system. If you have a small system that you want to run on top of a single server to see how it will behave, we can start consulting with you on what it will take to fine-tune that system. We have an HPC and AI innovation lab down in Austin, which is a large supercomputing lab that we can help deploy large models on if you want to do testing and simulation. And we just put it all together with our data scientists and experts from NVIDIA, all in a partnership to help you move to this AI-proven environment. Okay, so that's it for my talk. Does anyone have any questions?